Alright, so this is the latest version of my universe simulator running my unified theory of everything. Here, let me restart it. So, let's go to... Now when we restart it, we're restarting the simulation. It's not really the universe, obviously. It's just a simulation. I don't know if I really even need to explain that. Now every time I push enter, it is going to progress by one time step. And what we are going to see is that every time there's a time step, it just gets a little bit more optimized. So the top and bottom halves here, you'll notice it's in two sections, and they're identical for the most part. Each is a time step. This is a time step slower than this one. And I had to process these in parallel because of how computers operate. Computers are sequential, and the universe, everything happens at the same time. So I had to use some trickery to make it work, and I had to therefore have this then all placed in here and then computed. Otherwise it screws up the algorithm. So what's actually going on here? So red and high energy, black is actually negative energy. So this is new. So this is the first version of this simulation that includes negative energy, which I found is important. So the simulation is getting better and better. The equation is the same. The equation of everything, the unified theory of everything equation, it's the universe is infinite energy divided by infinite space. So if you look at the equation, the first half of the equation, this is the energy part of it, and then this is the space part. So there are only 5.33 units of space in this simulation. In the universe, in the real universe, that's infinite. There's an infinite number of space points and infinite energy that corresponds to every point of space. That's not calculatable. We cannot calculate the true universe. Not even a centimeter of it. We cannot calculate truly, not in totality, even a centimeter of the real universe. And I don't think we ever will be. I don't think this is a technology barrier. I think this is a barrier of finite beings. We are finite beings. We will never be as powerful as the universe, ever. And but we can improve our simulations. So here, all my computer can run is 5.33 units of space before it'll crash if I try anymore. But you know, if I was running this on a supercomputer, maybe I could have like 1 billion points of space. We can keep on optimizing so it's closer and closer to the actual universe. So what really blew the doors off this equation was that each square is infinite. So in reality, the universe is infinitely large and infinitely small. This was one of my insights that really blew the door off this whole thing, is that, okay, so if the universe is infinitely large, the inverse is infinite smallness. If there's any kind of floor to the simulation, then this fluid, it pools and it loses viscosity and it just stops flowing. I know I'm kind of rambling. It's really late at night. It's really late right now. Actually, it's in the morning. It's really early in the morning. And I'm just trying to get this out as I make progress on the simulation. If you followed my other videos, you know that I'm fully capable of putting together a very succinct explanation, and I will at some point, but that's not right now. Now I'm just getting this out there as quick as I can, and while I make progress on it. So the equation here, it's accounting for infinite smallness inside of each square. So this isn't just the square that you see. You know how the square is made out of pixels? The universe is like that too, except those pixels, they go in forever. You can zoom into any point forever. And by including that, or the approximation of that into the formula, it transforms the formula from a simple superfluid equation to a perfect fluid equation. So accounting for that, and I know this sounds like woo-woo, it's really not. This is very quantifiable. It is an actual formula that is approximating the theory of everything, which is uncomputable. And in the video, the nicer video I'll show you what I mean, and it'll be very clear. There is no woo here, no woo-woo here. There is no. This is very logical, and you'll see it when it's all laid out. You can zoom into a square forever, and that has to be accounted for when you're creating these averages. And when you do that, all of a sudden this liquid, it stops equilibrium. It stops reaching equilibrium, and it starts becoming discrete units, and that's what you can see here. But then the problem is, if you only have positive numbers, then what happens is it just starts to clump into higher and higher energy densities. So then the other breakthrough I had is we have to have negative numbers, and the negative numbers represent the fluid traveling into smaller scales, and the positive numbers represent fluid traveling out of scale into greater scales. This is extraordinarily logical. A particle, it pulsates, and pulsates, of course, not the technical word. I'm just trying to speak in just common language here. But it pulsates and it creates vibrations that ripple out, and that's what we sense as light, right? So it's creating energy that's expanding into bigger scales of reality. That is what a wave is. It is a ripple of energy expanding into bigger scales of reality. These negative numbers, that's the inverse of that. That is the inverse of a wave. I mean, it's actually remarkably logical. And so what happens is there is less positive energy than negative energy at our scale of reality. And so the result is that the negative energy surrounds the positive energy. The reason why an atom is discrete, as opposed to flowing, the energy just flowing everywhere, and why it's contained within a discrete unit, is because it's surrounded by this negative energy. The negative energy, it's simply energy flowing into smaller scales of reality, and while the atom is trying to escape into bigger scales of reality. It's the equivalent of two rivers flowing in the opposite direction. That's why atoms don't touch generally. We can force them to touch, but generally they don't, because they're being separated by this ocean of negative energy. And you might be thinking, oh, if it's negative energy, my phone's going to run out of time, by the way, so I'm going to try and fit in as much as I can. I'm running out of space on my phone. But so then a black hole is the greatest manifestation of this negative energy. You might be wondering, well, if empty space is negative energy, then why is the universe expanding? Okay, well, here is okay, buckle your seatbelt. Here is one of the most bizarre aspects of optimum theory. The universe isn't expanding. Okay, we are shrinking. Okay, I know how crazy that sounds, but according to the math, that's what's going on. Because you heard time is relative, all that. Size is relative. Okay, because the universe is infinite, it's infinitely discrete. So it's not really shrinking. We're just kind of falling into smaller scales. Is what's going on. It's making it look like everything's expanding. That's according to that. My phone's going to run out in like 20 seconds. I don't think I forgot anything. If I think of anything that I forgot, I'll upload it later. But if I keep on optimizing it, you'll see it'll just keep on making more and more discrete units. It's really awesome. What I'd like to get is a more powerful computer to run this. Okay, phone's going to die. Talk to you later.